So this video is an explanation of how to write a Kc expression for a homogeneous equilibria. Homogeneous is when everything in the equilibrium is in the same state. So this example here, the Haber process, is a homogeneous equilibria because everything's a gas. So everything's in the same state. So our Kc expression is the concentration of your products raised to the power of their molar ratio, the big number in the equation, divided by the concentration of the reactants raised to their molar ratio. And if you have multiple products or multiple reactants, you would multiply them together, not add them. So let's apply this to this question. Our Kc will be equal to our products, which is ammonia, the concentration of, that's what those square brackets means, raised to the power of their molar ratio, which is 2, divided by the concentration of our reactants, which is N2 and H2, raised to the power of their molar ratio, which is 1 and 3. So filling that in for this question, it says at equilibrium we have the following concentrations, and a point of clarity, you must use the equilibrium concentrations. The definition of Kc is the equilibrium concentrations. Kc is the equilibrium constant. So if I had concentrations that were not at equilibrium, I could not put them in this equation. Well, I could, but it wouldn't give me Kc. So let's feed in these values. So the concentration of ammonia is 4, so 4 squared. Nitrogen is 2 and hydrogen is 1, so 1 cubed. Bang all that in a calculator and we will get 8. Now in terms of the units for this number, each of these concentrations has the units moles per decimeter cubed. So in my Kc expression, I have 2 moles per decimeter cubed on the top. So moles per decimeter cubed twice. And on the bottom, I have a total of 4 moles per decimeter cubed, 3 and 1. So bear with me a second, I'll write this out. We can then cancel our units, so a moles per decimeter cubed on the top will cancel 1 on the bottom, same there and same there. That will give me a 1 on the top, and we can condense these together. If I've got a moles and a moles, that would add up to a moles squared. If I have a decimeters to the minus 3 and a decimeters to the minus 3, that will add up to a decimeters to the minus 6. And then finally, we can't leave these units on the bottom of this fraction. We need to flick them to the top of the fraction. And the way we do that is by reversing the sign of the power. So decimeters to the minus 6 becomes decimeters to the 6. Moles to the 2 comes moles to the minus 2.